Welcome to your tutorial on z-test. So a z-test is a statistical test that determines whether there's a significant difference between sample data and a population. There's lots of different types. So the first one is one sample z-test, which compares a mean of a single sample to a known population mean. There's a two sample z-test, which compares the mean of two independent samples. And we can also compare proportions from a sample proportion to a population proportion. Now, the formula for a z-test is going to look a little bit similar to what we've already done, except now we're using the sample mean, which is x bar. You may see this written as x bar, or you may see a little x with a bar over top of it, a line, minus the population mean divided by this part of the formula, which is standard error of measure, which is the population standard deviation minus, and this little symbol right here means the square root of the sample size. All of that is explained right here. So again, the purpose of a z-test is to assess whether a sample mean is significantly different from the population that we're looking at, and to see if those observed differences are due to chance or if they're actually due to what we're trying to study. So how do we do a z-test? This is going to be our first hypothesis test that we're going to do in class. A null hypothesis assumes no difference, and this is our tested hypothesis. So we're always trying to test if there's no difference. Alternative hypothesis assumes there is a difference. For our significance level, or alpha, we're going to start with 0.05. That's where we start with social science. And if we find that this is significant, then we may want to also test at 0.01 or 0.001. Now, when we do JASP, it's going to actually give us the actual p-value, and we won't need to use the alpha because we'll get the exact p-value. We're going to calculate the test statistic, and then we're going to determine the critical value. So this is a difference between when we're doing it by hand and when we're doing it in JASP. When we do it in JASP, we're going to get the exact p-value. We don't have to worry about the critical value. When we're doing statistics by hand, we have to create a zone of critical value. This is going to help us determine whether we reject or fail to reject our null hypothesis. So when we have a one-tailed z-test, we're going to say either that something is less than, which would be over here, or more than, and we can put all of our chance on one side of the chart, so to speak. For a two-tailed z-test, when we don't specify the direction, which we do a lot in dissertation work, we are going to split the difference and spread our chance on either side so that we can see if we're going to be able to reject. We'll then draw our results. I always recommend drawing your results because that's really important, and make a decision on whether or not it is in the fail to reject or if it's in the critical zone of reject. So I'm a football player, a football star, I can't even talk tonight, a football fan. So I like it when, we get a field goal. And so I always think about these as kind of like goalpost. And when I'm in statistics, if my ball goes between the goalposts, I'm going to fail to reject. If my ball goes outside, I'm going to reject the null hypothesis. So that's just the way I remember it. So here's an example. We have a population mean of 106.46 with a standard error measure of 19.13, which gives us our, map here. And we're doing a critical value of plus or minus 1.96 because we have a p-value of 0.05. And I know that when I have a two-tailed test with the p-value of 0.05, that my critical value is plus or minus 1.96. So that creates the zone here. So if I take a score from this population as a sample, and that sample falls somewhere in here, I'm going to fail to reject. If I take a sample and it's outside those goalposts, I'm going to reject. So here's the comparison of z-scores to z-tests. Z-score measures how far a single data point is from the mean, whereas a z-test compares differences between the population and the sample data. A z-score can be used to standardize individual data points. A z-test compares those data points between the population and the sample. There's different formulas. Page just skipped, sorry about that. Z-score is Z equals X minus mu divided by the standard deviation of the population, versus Z-test is the sample mean minus mu divided by the standard error measure. For Z-scores, I'm going to indicate how many standard deviations a value is from the mean. For Z-test, I'm going to determine if the observed difference is statistically significant and not due to just chance alone. So, purpose of, we're going to look at a mean here, we're going to look at a research example. The purpose of this study is to decide whether a new mindfulness meditation is effective in reducing stress levels among college students. I would say, okay, we'll just stick with this for now. The research question is, does the new mindfulness meditation significantly reduce stress levels among college students? And then we are going to set a hypothesis. If you had given me these purpose statements, I would probably have you change, and I'm going to show you this. I would change this to effective in impacting stress levels. And then the same thing here. Unless you had a lot of evidence already to support this, I would encourage you to use a two-tailed test. So we're going to do that here. All right, so does a new mindfulness meditation significantly impact stress levels? So I'm going to reduce my bias that I think it's going to reduce, unless I have enough research to support that already, and I'm just trying to continue to test it and expand the research that's on it. So for this, I'm going to state my hypothesis, my null hypothesis, which the new mindfulness meditation does not significantly impact stress levels among college students compared to the national average, because I want to be open to, is it going to enhance? Is it going to reduce? Is it going to, what's it going to do? My alternative and non-tested hypothesis is going to be that it doesn't significantly impact. All right. So we're going to set our significance level, or alpha, at 0.05. And then we're going to collect our data. So we've got a sample of 40 college students who participate in mindful meditation. National average, which is our population mean, is known to be 60 with the standard deviation of 15, and our sample mean was 55. So the stress level for our sample mean of 40 students was 55. So we use this formula, should look familiar, it's just written a little different. Calculate this out. So our Z equals 55 minus 60 divided by 15 divided by the square root of 40. So this talks about how I calculate that. So here's how I'm going to calculate the numerator. Here's how I'm going to calculate the denominator. Put them together and get an answer of negative 2.11. So the critical values for Z are common. So this is cool. I don't have to really look this up because this is going to be the same. If I have a one-tailed test, if my alpha is 0.01, here's my critical value. If it's 0.05, my critical value 0.01, 0.001. We're doing a two-tailed test, so we're going to want to look along this chart. And in this case, I know that I chose an alpha of 0.05 to get started. So it gave me critical Z value of plus or minus 1.96. And here's another chart to help you with that. So if it's a one-tailed, if it's a two-tailed. And since we set the significance level of 0.05 and we have a two-tailed, our critical value, like I said, is plus or minus 1.96. So for two-tailed with a significance level of 0.05 with a critical Z value of plus or minus 1.96. So our goalposts are going to be that 1.96 below the mean and 1.96 above the mean. And our calculated or obtained Z value is approximately negative 2.11. It would be written like this. So let's visualize it, right? We're going to draw our distribution, label our mean, indicate our critical value, and plot where the sample mean falls. So in this particular case, we've got our normal bell-shaped curve. Here's our goalpost of our critical values, our mean. Since this is negative 1.96, negative 2.11 would be to the left of it. So it is in the rejection zone. I'm going to reject my null hypothesis, since negative 2.11 is less than negative 1.96. How do I interpret this? The Z value of negative 2.11 falls in the critical region of the Z critical Z value of plus or minus 1.96, leading us to reject the null hypothesis. It indicates there is a statistically significant difference at the p-value of less than 0.05 between the stress levels of college students who participate in the mindfulness meditation program and the national average. Therefore, we conclude that the new mindfulness meditation program significantly reduces the stress levels of college students. I know it's reduces because I have a negative 2.11. So again, here's my steps that I took to get that decision and information that I should include in my interpretation. And here is another version of that interpretation, that narrative description. That is your tutorial on T or Z test. I hope this was helpful.